Hello everyone. Today we'll be covering May June 13, paper 42, question 2b of CIE A-level chemistry, code 9701. This question was relatively difficult for a majority of the candidates that sat the exam, mainly because it also involved a link with mathematics. So let's proceed. The question began by saying that it's a buffer solution that has been made by using 1 mole per dm cube, which is the concentration of ethanoic acid. So that's our acid. And 1 mole per dm cube of sodium ethanoate, and that's our base. This actually isn't the base, that's just a salt. The actual base is CH3CO2 minus. Why is this a base? Because it's negatively charged, so can accept a proton, i.e. H plus, and therefore is a Bronsted-Lowry base, right? So you are asked to calculate the volume of addition of the acid and the base to the nearest 1 centimeter cube to make a total of 100 centimeter cube volume, right, of pH 5.5. So how would you approach this question? Well, to those that are familiar with, again, you don't have to get it instantly. So those that are familiar with buffer solutions will be familiar with this equation. Concentration of base by acid. This equation, like a lower variant of it, is basically this equation. Is equal to Ka times concentration of HA divided by concentration of A minus. This equation is basically the Ka equation with H plus made the subject and the concentrations of H plus and A minus not being equal like we normally do with weak acids. And so first what you do is tackle the easy stuff. So calculate the concentration of H plus. So using this equation, pH is equal to minus log H plus. Let's correct algebra. 10 to the power minus 5.5 is your concentration of H plus. Okay. Now, how would you approach this? This is where most candidates came to a halt because it also involved making something the subject and canceling things out. And let me show you what should be done. So this equation is also something that most candidates are familiar with, right? N is equal to Cv. Now, in an ideal buffer solution, as in where both moles are equal of acid and base, the pH would be 7. However, that isn't the case here because the pH is 5.5. That means in the buffer solution, there's more moles of one and lesser moles of the other. In a sense, more moles of the acid or the base and lesser moles of, what is lesser moles of the other. So you make concentration the subject, N by V, right? So you substitute that Ka times the concentration of the acid would be moles of the acid divided by the total volume, whole thing divided by moles of the base by the total volume. Now you may be questioning why the total volumes are over here and over here are equal. Well, that is because when both the solutions, as in the acidic and the basic solutions, are added together, their concentrations are calculated in the final solution. So let's say you have 20 centimeter cube of an acidic solution and you have 80 centimeter cube of a basic solution, okay? When you add these two together, you will get 100 centimeter cube, right? And if you're asked to calculate the concentrations of the acid and or the bases in this solution, you will use this as a total volume. You won't be using these individually anymore because they're part of one solution now, right? So that is why this Vt and this Vt are equal. Let me just rub this out. So because they both are equal, they cancel each other out. So concentration of H plus is equal to Ka times the moles of acid divided by moles of base, okay? And in the question, they've made it so much easier for you. They've made the concentrations of the acid and bases of like their independent solutions 1. So N is directly proportional to V, and where C is the constant here. So because C is 1, N is basically volume. The moles is basically volume, and therefore the concentration of H plus is Ka times the volume of acid divided by the volume of the base. Now you make VHA by VA minus the subject, and it'll be a ratio of the concentration of H plus and Ka, right? So let me just clear some space up so that I can do the working. So the ratio of VHA by VA minus is equal to 10 to the power minus 5.5 divided by the Ka value that's provided in the question. So 1.79 into 10 to the power minus 5. That, if you calculate, will be 0.177, rounded to three significant figures. So therefore VHA is equal to 0.177 VA minus, right? Now this is your equation. This is what you'll have to follow. And they've told you that the total volume is 100 centimeter cube. So VHA plus VA minus will be 100 centimeter cube. You just substitute VHA is equal to 0.177. So 1 plus 0.177. So it'll be 1.177 VA minus is equal to 100. And therefore the volume of the base that is required, which is basically VA minus, is 100 divided by 1.177, which if you do is 85 centimeter cube. And this is the base, 85 centimeter cube. Now from here on you can either approach this by, well, the total volume is 100, so 100 minus 85 will give me the answer here, or you could substitute this VA minus value into this and calculate the volume of HA, or the acid, which is still going to give you the same answer. The final answer is 15. Okay, I hope you understood. You don't have to take on every single step. If you're confident in yourself mathematically, you can skip a few steps here, like just convert this directly into like this instead of, you know, doing it every single step to avoid using up so much space. And yeah, that is it. If you have any doubts, please do leave them in the comment section below. Once again, I hope you understood.